We're going to talk a lot about 3 moon missions that are going on right now. Well, actually, one of them just finished up, so there's only 2 left. But there's 3 moon missions here. One for Blue Ghost, which is an amazing success. Firefly is the name of the company. Intuitive Machines, they're a notable failure. And the third one is a Japanese one, which launched a while ago, and it hasn't landed yet. It's still en route. So we'll talk about each one of these in turn. So first, the good news. The Blue Ghost, which is by Firefly, which is a Texas company, they landed on March 2nd. Now this, along with some of the others, funded in large part by NASA through their Commercial Lunar Payload Services program. Basically, the companies sell a service of essentially trucking stuff anywhere, in this case, to the moon. Now, we talked about this before, actually just last month, in fact, so I won't talk about a lot of the details that I've covered before. But one thing to say about this is it was the first 100% successful commercial soft landing. It didn't tip over in particular. That's been a problem for some of the others, yeah. And it did land within about 100 meters, 330 feet of the target zone. Just to give you a feeling on the size, it's about 1,000 pounds. It has 10 NASA payloads in it. It's under 7 feet tall and under 12 feet wide. Okay, some pictures to show you what this thing looked like. Now that's mounted on a Falcon 9 rocket. There were other loads that were going into that thing. That's called the fairing, the container around the back. There were at least 3 other loads. Another lunar lander, the Japanese one, and also a couple of satellites. We'll talk about those. Okay, so we'll have some pictures of the spacecraft on the way to the moon. So this is actually after they've gotten into their first lunar orbit. They start out and they go from Earth and they went out to the moon, but they are in a very elliptical orbit and they're not that close to the moon. They go through several corrections until they finally get down to a very low orbit. This is the relatively high orbit. What you're looking at here, you're looking up from the bottom of the spacecraft to the top. That's a radiation sensing instrument, which I think actually was taking recordings all along the way. Now, this is when they got down within 60 miles or so. This is their final orbit before they actually decided to land. And they did multiple orbits around the moon before they finally landed. And this is after the landing. What you're looking at there is the shadow, and you can kind of see the landing feet. The big thing in the center of this shadow is the nozzle for the big thruster that they had. And that's apparently a crater in front of it there. Keep in mind, this is basically sunrise on the moon. They all try to land early in the morning because they're only going to get 1 lunar day because they don't have any kind of heat source that could take them through the night. So all these landers just typically last 1 lunar day, which is 14 Earth days. So that's what it looked like looking with the sun behind them. And then looking the other way, they got this great shot of the lunar sunrise. They didn't watch the sun come up. It was already sunrise when they landed, but that's what it looked like. Now, they had quite a few payloads. I think almost all these were paid for by NASA. And I put green check marks by payloads that were completed, or at least very, very close to being completed. This was as of 2 days ago. At least 8 out of the 10 were essentially considered complete. And there's a few others that it's not clear what the status is yet. I'll talk about just a few of these, so they're kind of interesting. The one down here, the 9th one on this, which is the bottom near the right, the GNSS receiver, that's Global Navigation Systems. That's a generalization of GPS for Global Positioning System and the Galileo system that the Europeans run. They found that on the moon, they can access that. So this is actually, yeah, that was fairly interesting. They did the same thing in space. On the way there, they tried it, and they also found that even farther away than the moon, they still could navigate with that. They can actually listen to the existing GPS satellites. You would really think these satellites would have directional antennas pointing downwards toward Earth, but apparently enough signal leaks through that they can make it. So even at 243,000 miles in space, they were able to still receive those signals. So there are some possibilities for navigation there. Now, that won't help on the far side of the moon, obviously, but at least on this side, it's pretty good. These other ones, it's hardly worth going through all of them. I will talk about one that's kind of fun, and that's PlanetVac. There's a vacuum. What's it for? They want to vacuum up the moon. Well, actually, not all of it. All they want to do is get samples. And think about that. You'd like to have a vacuum cleaner, basically, because there's a lot of lunar dust. You'd like to see what's in it. But a vacuum cleaner isn't going to work on the moon because you're already in a vacuum. You can't suck anything beyond that. So what they're doing instead, they have high-pressure nitrogen stored, and they shoot it out. And what they do on these bottom ones here, the ones closest to the end of it, they stir up the dust. They say, like, makes little tornadoes. They must be going at somewhat of an angle. Then you have a separate one up there, which then shoots the nitrogen to carry in the dust. This is the same thing. They have an arm that just falls down, and that was this arm right here. They had a lot of interesting experiments. An awful lot of these are really oriented toward making it possible for humans to spend more time on the moon. I mean, for instance, the electrostatic dust shield. Dust is a major problem on the moon because it's so jagged. There's no erosion, there's no wind, so it's just like little tiny shards of glass. And that's a problem. So how do you stop all that dust from getting in machinery or getting into your lungs if you carry it back into your habitation module? Well, it turns out you can use electrostatics, static electricity. And they actually tested that they can repel the dust, and if they want to, they can use it to pick up dust. They actually tried both ways, and it all seemed to work out. The main thing is NASA had a lot of payloads, and they're getting them all done, and that's really a first. Most of the times in the past, when we've launched one of these things, they tipped over, and they could run some of the experiments to some extent, but not completely. The second one is Intuitive Machines, a Houston company. They had the Nova C lander, and this is mission 2 for them. Their first mission was one of the ones that tipped over partially. And so they were able to get some of their experiments done, but it was obviously less than satisfying. So they took partial credit. They got part of a landing for it. Now, this one is a little different. They're going very close to the South Pole, about 5 degrees north of it. That was the southernmost lunar landing. That's a tough area for a couple of reasons. One is it's kind of rough terrain. But the other thing is that the shadows are very, very steep there. It's kind of tough at the pole because you really have trouble figuring out, well, where are the edges of craters and that sort of thing. And that may have been part of their problem. We don't know that. Now, they did try for a very high plateau. It's about 20,000 feet up, called Mons Mouton, which actually is named after a mathematician. You might think it was named after sheep, but no. If you know Latin or French, you'd recognize that. But no, it's actually named after a mathematician. Anyway, there's a high plateau, so that's relatively flat, and they thought they had a pretty good shot at landing there. And we talked about the plans on this one before as well as the previous failure. But just to briefly recap, it was funded by NASA, a total of about $120 million for the delivery service and the payloads that were contained in it. Again, it's CLPS, and also some funding from a separate NASA program called the Tipping Point Technology. That was specifically to put a cellular phone network in place for transmitting data back and forth between this lander and actually a couple of rovers that were going to be out there. And this is tall. This is one that's tall. It's 13 feet tall. It has a payload of about 300 pounds. Now, the big single purpose of this that really NASA paid most of the money for was this drill. They were going to drill down 3 feet, 1 meter, and look for water, basically evidence of water. And what they do is they drill down any volatiles that were in there, anything that got vaporized, basically. They'd pick up with a mass spectrometer to analyze it, to recognize, in particular, looking for any hydrogen-bonded kind of stuff. And the bulk of the NASA payments really were for this particular payload. Now, the day they landed, March 6th, they had a press conference basically to say, well, we're kind of in trouble, guys. They're saying they did land, and the solar cells apparently were charging somewhat, but at reduced rates. And the lander was receiving commands and transmitting, and they could even talk to individual payloads. So a lot of things were sort of okay, but nowhere close because everything was at a reduced rate. Now, if you've watched any of the previous missions like this, as soon as they say your solar cells aren't providing much power and you're transmitting at reduced rate, you think tipped over, which turned out to be true. Because you have reduced rates, well, one, because you don't have as much power, and the other thing is that probably some of your antennas are not pointing in the right direction, or they might be broken off or hidden on the bottom of the thing, So it was pretty good. At least they managed to get some data. So they prioritized getting pictures back, and they finally did get one. All they could tell as of the time of this press conference was that it looked like it was tipped. The angle was kind of uncertain. So they shut down all of the really non-essential loads, which is almost everything, and they're waiting. But then the very next day, the 7th, they've had this picture, and this kind of said it all. What you're looking at here is the thing toppled over into a crater. You can see the landing legs are kind of sticking up in the air. In the middle, in between these two legs, in here is actually that drill, which is going to drill down 1 meter. So it's pointing out it can't even reach the ground. That pretty much said they're in big trouble. There aren't really a lot of solar cells up here, so they just pretty much realized they had to run on battery. That's about the best they can do. A lot of people thought, well, maybe something can be done here. Maybe the rover can escape. They had a hopper, which is propelled by rockets. You think maybe that can escape. Apparently, it wasn't accessible here. So what they found out, though, from the data they did get, is they did land within 800 feet of the target. and they were trapped inside of a crater. But it turned out there's just not enough sun to power operations, so they knew they had a very limited life ahead of them. And the problem is not only that there's not enough sun, but also when you're down inside of a crater, those craters are really cold. They're actually even colder than the surface because they never see the sun, or at least they don't see it very long, depending on how deep the crater was. They said for that, well, when you have a lot of thermal stresses, because you have huge temperature differences, but also you need more power to heat the thing. And so if anything, you're going to run your power down even faster. And also one of their 2 radio antennas was not in the correct orientation. So you put all those things together, and yeah, that's why they didn't get good data rates on their data transmission, and that's why they weren't getting much power. So they realized they're just going to run it till the battery is exhausted, and that's pretty much it. Now, one thing, in the previous day on the press conference, they had mentioned that the altimeter, which was a laser-based rangefinder, was noisy, and that was unusual. They hadn't expected that, because most other landers haven't seen that before. Maybe that contributed to the problem, maybe not. But that was already, they were suspecting there could be a problem with that. I have to say, a lot of people have commented, including me in the past, that when you have these really tall landers, it just seems like you're asking for trouble. You land on too much of a slant, or you hit a boulder or something. It just seems like you're going to tip over more easily. Why do they keep doing that? Well, so a lot of people have pointed to that as an example, but it seems to me that if they landed in a crater, the real problem was they didn't do a very good job of figuring out where the craters were, because they have a target area, and they picked out like a 250 meters or so, circle, something like that. And the idea is you want to land within that, but the final decision on where to actually land is made autonomously by any of these landers. It has to be, because these are all small little craters, and it could be boulders that are only a couple feet or even a foot big. That's enough to really screw these things up. So they have to make that final decision. Now, who knows what happened there? If they thought they were higher off the ground, maybe they thought they had more room to go. You can't tell. But I'm hoping they get enough data out of this that they can at least figure out why they had the landing problem. The previous time when they tipped over, they had 2 problems. One was their altimeter wasn't working at all, and as a result, they misjudged how high up they were, and they landed really too fast just because they misjudged things. And they landed on an angle, and then the leg broke. And then the whole thing toppled over. Now, this time, it's actually worse because they fell into a crater. So I'm thinking they had trouble just figuring out where they were.
A question arose. Given the problem with the laser rangefinder, why didn't they also navigate using cameras?
Well, actually, most of the other landers do use some optical positioning. In fact, I think after the last experience, I think they did as well. The problem is at the South Pole, when you're very near sunrise, it's very, very hard to make things out. And so they were saying this is a tougher landing place, even than normally you would expect. So we'll see. We'll have to find out what happens. Now, they did claim that they accelerated some payload milestones, meaning they sat there and they said, okay, what can we do to make sure we get the maximum payment out of NASA for whatever we did? And so what they did was they claimed that they did something with the drill. Now, the drill is pointing up in the air, but it is movable. It was not necessarily fixed in position. Maybe it could move 30, 40 degrees. I don't know. And apparently, at least they showed that it could move around. So they did some experiments like that. They had communicated with most of the payloads. So actually, even that is useful information because it meant that all those payloads survived. So for instance, the rover, they couldn't run it, but at least they were communicating with it, indicating it had survived the landing. So, all that gives them information, but obviously they still failed. So it's a shame, really. They had a lot of interesting technology in here. They had a great rover. It would have been a good thing to have done. This, like the Japanese one we talked about last time, they're going to sell some regolith to NASA, meaning lunar dust. They're going to sell that to establish the principle that you can extract resources and then sell the resources. And this was the second lander that was going to be doing this. Obviously, that's not going to happen.
A question arose on how payments are made for payloads when the lander fails.
I don't know how they figure out how much to pay the payload people. This Lunar Outpost is a Colorado company. Their whole mission was paid for actually by Nokia because they were going to drive out a mile away from the lander to show that you can have a cellular network and communicate, and it'll all work just fine on the moon. So that was paid by Nokia. Nokia, in turn, was paid by NASA. They did everything. I mean, they probably should get fully paid for this. So, it's kind of hard to say. I don't know the answer. I actually did some digging. I couldn't find much of anything on that level of detail. We talked about this one. There's a rover on top of the rover called a microant. It was really done out of MIT. You can see it circled there in that little white circle. It was just going to run around and measure temperatures. But the point of that was it is a prototype for swarms of robots in the future. For instance, might go and do inspections on a spacecraft, not necessarily just in landing. But this is kind of the extreme test. Can you even do this on the moon? They had a hopper that could carry a couple of pounds, 1.5 miles, or you could carry less and go farther. The last time we talked about this, it looked like the middle picture there. And then the most recent ones look more like the ones on the right. They don't look much at all alike. But the main thing they have in common is they all have thrusters and they can hop around. And the intention was to do 5 or 10, I guess 5 hops were planned. The idea is you go down into those craters. You can't just drive into a lot of them. They might be too steep, but you could fly down there.
A comment was made that the hopper looks like it might tip over too.
Especially you look at that one on the right and you think, my gosh, how's that ever going to work? So I don't know. Now, the good thing is the gravity is lower on the moon. So, the amount of force exerted when you're tipped is not going to be as much as it would be on Earth, or even Mars for that matter.
But unfortunately, if there's also some horizontal velocity while you're landing, that force for tipping is independent of gravity.
They also had a small Japanese rover that weighed about a pound, that thing on the left there. I don't actually know what that was going to do, other than work as a test platform for the Nokia cellular communications. Other payloads.
We already talked about the Nokia cellular communications. There was also a payload to monitor radiation. And there was also a payload from Lone Star Data Holdings, a Texas company that wants to offer a data backup service on the moon. They had a small server as a demonstration.
Okay, the third one is the one that's still on the way, and that's the one from ispace, which is a Japanese company. And as I pointed out last time, that's not to be confused with the company called ispace out of China, which has a dash in between the I and space. So these guys actually were first, so they weren't copying. Their rover is called Hakuto-R. This is their second mission. Their first mission also tipped over. Same kind of problems, and we've talked about these before. But what I want to talk about is where they are. Now, we had a similar map last time. This is just a little fancier looking one where their path to get there was very energy efficient, but it takes a long time to get there. That's why they launched the same time as one of the other landers, but they're still only halfway there. Where they are now is out the far point shown on this orbit map. What they're showing here is that they'd circled the Earth a couple of times. I don't think they were actually applying thrust because they're not showing the orbits growing here. I think all they were doing is taking time to test out all their systems. Finally, they decided to shoot for the moon, so they go out and they go way, way out. What they were doing in particular is they're doing a flyby by the moon, take advantage of the moon's gravity to help pull it along. It was working that way because the moon, by traveling around the Earth, it's going faster. So ultimately, this thing had to get a little bit of an extra boost. And that is the reason why they're such a low energy orbit. They're taking advantage of a lunar flyby here. Anyway, they're out, they're going way, way past the orbit of the moon, and they're on their way back now. And then when it gets in closer, it'll look like that. Okay, one thing that's interesting about them, this is just from their webpage, their About Us page. They're saying they want to live in a world where the Earth and the moon are one ecosystem. Now, that seems like a stretch because there's not a whole lot of biology going on the moon. But I think their point is that ultimately, at least there ought to be an economy that gets developed here, eventually involving humans and machines. And we need to start thinking of the system in a little bit bigger way as one big unit. Anyway, I thought it was interesting that that's their viewpoint here. Okay, there was a Falcon 9 rocket that sent up 2 of those landers that we just talked about. They also had a couple of ride shares, meaning additional loads that just went along for the ride. This one is a 265-pound spacecraft. They were heading out actually to survey an asteroid. And what they want to do is ultimately mine that asteroid. And they lost it. They lost the communications, essentially. And it looked like they really had a lot of problems in the beginning. They didn't really do a very good job on coordinating with the ground stations. They hadn't tested them out fully. They even had interference from a cell phone antenna. All kinds of things happened. I think they lost their ability to communicate with this device early on, and that made it that much harder to recover. The problem they have now is that the thing has been out there. It's 270,000 miles away, and they don't know exactly where it is. And it takes a very directional antenna to do a good job of communicating like that, and they're figuring it's probably doomed. They'll look a little bit further, but it's probably pretty much over. And there's another one that also went up in that same rocket, and it's also in trouble. This is actually directly a NASA satellite built by Lockheed Martin called Lunar Trailblazer. What it was going to do was circle the moon and look for water and minerals and landing sites, all those things. That cost them about $100 million, which is relatively cheap for a NASA-built satellite. But somehow along the way, they lost communications also. And they know their power is low, things probably spinning. Once it starts spinning, you have trouble because you lose communication. You have a hard time getting data or even transmitting commands to have it do anything. It's probably doomed. Now, they're going to keep trying. At least this thing is still going to be in orbit somewhere between the Earth and the Moon, probably orbiting the Moon. So they're still hoping that maybe they can salvage something out of this. They're going to keep trying, but the odds do not look good right now. Okay, Starship, totally separate topic here. Results came back from Flight Test 7, which is the previous one that blew up. The second stage blew up and generated this beautiful display in the sky. Everybody liked the way it looked. Not everybody was happy that all those pieces fell down.
Went over the Turks.
Yep. Well, they essentially blew up in the same place on the next test. So they didn't manage to fix all their problems, apparently. So they did come to the conclusion that it was vibrations. Now, they say harmonics, and the reason to think of that is almost anything has natural frequencies where it can vibrate easily. You think of a guitar string or piano string. If you pluck it a little bit, it tends to vibrate at a certain frequency, and also twice that frequency and 4 times and that sort of thing, the harmonics there. Even freestanding structures have these kind of vibrations, and they think that pretty much with all the noise and vibration that comes from the engines, apparently it really caused something to resonate very, very violently. That caused propellant lines to leak, and that led to ultimately ignition and fire because it was all inside the vessel, so there was oxygen and methane present there. Finally, the flight termination system, the safety system, blew it up, which it should have at that point, and it did. Now, they did a lot of fixes. So, Flight Test 8, this was supposed to have fixed that. They tried all the fixes on it. Essentially, the same thing happened all over again. Flight Test 8 was basically a rerun of Test 7, trying to redo all the things that didn't succeed on Flight Test 7. In particular, they wanted to test deploying satellites. I mean, that's a very high priority for them because they want to start getting the bigger Starlink satellites out there. They had new heat tiles and fin positioning, which hadn't really been tried yet. They had reentry experiments. They wanted to make sure that if they start to put little arms sticking out the side so that they can catch them with the mechanical chopsticks, will they be able to do that without them melting off in the process? They don't know any of that yet. And it blew up again. So the booster returned to the launch site just like Test 5 and 7. They had a little bit of problems. The 2 of the engines didn't restart. When the second stage separates from the first, they have to turn around the booster and head back. And at that point, all their engines are supposed to light up except for the very outer ring. And a couple of them didn't, actually. They coast for a long time, basically burning off energy, getting hot. And then finally, toward the end, they have to turn the engines back on. And actually, one of those 2 came back. But they're still having some engines that aren't quite relighting the way they should. So nonetheless, that didn't stop them. They've got enough power in those engines, they can get by without it. So they caught the thing. But anyway, they lost control on the second stage. Pretty much a repeat of what happened before. The engines failed. They saw that on the displays. They lost control, and you could see the thing was starting to spin. They lost telemetry, and then there was an explosion. Presumably, the flight termination system, we don't actually know that yet. So we'll find that out later. So it's a shame, but they will go on. These tests don't actually cost them that much money. And this time, at least, it did disrupt aviation for a short period of time, but it was nowhere near as bad as before. And I don't think any debris hit anything this time. Everything fell within the original zone. When they make these plans for these flights, they have a zone that says, okay, people stay out of this zone because if anything goes wrong, stuff will fall here. And it did. And it looks like this time it all fell within the zone that it was supposed to. To wrap this up, a couple of interesting projects that are sponsored by the Air Force Research Lab. 2 different situations here. One is a company called Varda Aerospace Systems. We've talked about them before. They were the ones that first put up pharmaceutical manufacturing in a small capsule, circled the Earth. And the problem was they had trouble getting approvals to land. Most of the stuff that we send up, with the exception of things coming back from the space station, nobody ever thinks about bringing things back. Well, for the future, we have to. If we're going to do any kind of manufacturing in space, for instance, or bringing anything back to Earth, we had to be more set up for this. And they got so disgusted, the FAA took so long, they're going to Australia to land now. So their second test, they landed in Australia. This one's different than the first one. The first one was purely commercial, sponsored by pharmaceutical companies, obviously for high-value manufacturing. You're not going to make aspirin, in this kind of a thing. You're going to make really expensive stuff. But the second one, they're doing stuff with bioreactors, reactors that actually have biological elements in them. They were really just experimenting with that. But the thing was actually paid for by the Air Force because what they want is more data on what happens during hypersonic reentry. If you're coming back very, very high speed, like from a missile, they don't have much ways of getting data like that other than sending up missiles, which is a very expensive thing. This is a very small thing. But nonetheless, they do all these studies on the plasma all the way from the beginning right down to the end. So this is actually a project that's going to go on for quite a while with the Air Force. They put in some spectrometers for analyzing what exactly is going on. So the Air Force ends up funding what's going to help in the future with manufacturing in space. The second one is kind of interesting, and people have talked about this one before as well. The Air Force Research Lab has a rocket cargo program, meaning point-to-point delivery of stuff from one place to another. And obviously, they're the most interested in military applications. They're thinking, instead of sending giant cargo aircraft, which take a while, they want to get somewhere in just an hour. And so back in 2022, they actually set up a contract with SpaceX to demonstrate the technology, probably in 2026 or 2027. So it looks like they're getting more serious about this now. They obviously had to wait till there was even some hope the Starship was going to be a real thing. And it's getting closer. So now they're out getting approvals to actually land on a remote Pacific island, Johnson Atoll. This one has figured in U.S. military history for a long time. It's actually officially been a wildlife refuge since the 20s or 30s. But really, it's actually owned by the Air Force. They did nuclear tests there. At the end of the Vietnam War, when they had to bring back all the toxic Agent Orange defoliant, they built a plant there to dispose of that. And of course, then it took another 20 years to fix the dirt afterwards, but they finally cleared all that up. So they have a long history of all the oddball military stuff. And of course, they use it as an airstrip in World War II and for Vietnam as well. Anyway, now you're going to use that as a place to test out the point-to-point delivery. So that should be interesting to see how that comes along. Okay, just a few minutes on upcoming launches that are interesting. One of them is the Crew 10 launch, that is sending up on a Dragon capsule, on a Falcon rocket, sending up astronauts to the space station. About a week later, that thing returns, or a capsule returns, and that's going to have the so-called stranded astronauts. They were never really stranded, but we'll just call them that and let it go at that. Other things coming along we talked about before, Project Kuiper, which is a big satellite constellation. They may finally get their first operational launch. They haven't said that it's been delayed, so they're still talking about this quarter. Axiom has a private mission going to the space station. Dream Chaser, the space plane, that's still on target for May, as far as we know. And the other thing is there's some Mars satellites that are supposed to go up on a next Blue Origin flight. Then we have ones that are further in the future. The Neutron rocket, which is essentially Rocket Lab's answer to the Falcon 9.
Reusable.
Yeah, reusable.
A question came up about the Axiom space station and its schedule for decoupling from the ISS, the International Space Station.
The original plans were they're going to put up a habitation module and attach it to the space station, taking advantage of the air and the power and all that stuff from the space station. But then the space station people said, wait a minute, we're trying to deorbit the space station and we need the port actually where you were going to come up and attach. We need that for other stuff. So they switched things around and now they're putting up the power supply module first, which doesn't actually have to really be attached when you get down to it, but they're going to attach it for a while. And then later they'll have the habitation module going up. But in 2028, they'll decouple all of that and just be freestanding, which actually would be sooner than the original plans.
Intuitive Machines gets another chance up at that.
Yeah, they still have 2 more to go that they're contracted for. Okay, I think that's pretty much it.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.